Find the radius r of the circle of an arc of length 20 centimeters on the circle subtends a central angle of 50 degrees. First, when working with the circle, we should draw one. The central angle is measured using the positive horizontal axis, and so we would put in the x-axis, positive. The central angle is 50 degrees. 50 degrees is in the first quadrant, and so we would draw the terminal size that is in the first quadrant. It doesn't have to be accurate, but we will try to be proportional. This is a 50 degrees angles measured from the positive horizontal axis. The arc of length 20 subtends a central angle of 50 degrees, and so this arc has a length of 20 centimeters, and we're looking for the radius of this circle r in centimeters. The formulas that relates the length of the arc s, the central angle theta, and the radius r is s equals r times theta, but only if theta is in radian. As of now, we cannot use this formula, not yet, until we convert 50 degrees into radians. 50 degrees, to convert it into radian, we would multiply the factor of pi over 180 degrees so that the degree cancelled out. The unit is in radian. 50 over 180 is 5 over 18. Pi is pi, and so we would leave pi alone if we want the exact answer. S is 20 centimeters, r is unknown, theta is now in radian, which is 5 pi over 18. To isolate r, which is the radius, we would simply take 20, multiply the reciprocal of 5 pi over 18, or we can divide it by 5 pi over 18 both sides of the equation, but that end up multiplying 18 over 5 pi. The exact answer for the radius is 72 over pi. 20 times 18 divided by 5 is exactly 72, but pi is still in the denominator. The unit for the radius is in centimeters. Now, usually, we will need to report the decimal number for the radius. We can't just walk around and say the radius is 72 over pi centimeters. It doesn't make sense to a lot of people. And so, the radius is 22.92 centimeters, depend on how many decimal places we want to round it to. In this case, we round it to 2 decimal places.